Lecture 1, Module 3, Introduction to Lean. Another successful program that the pharmaceutical industry began to consider was lean manufacturing, or lean for short. Benjamin Franklin is recognized as one of the early thinkers on lean. He stated, on wasted time, he that idly loses 5 cents worth of time loses 5 cents, and might as well prudently throw 5 cents into the river. Well said. On unnecessary cost, a penny saved is 2 pence clear. Save and have. On unnecessary inventory, you call them goods, but if you do not take care, they will prove evils to some of you. Buy what thou hast no need of, and ere long thou shalt sell thy necessaries. And many have been ruined by buying good pennyworths. How many of us have fallen prey to 50% off sales? Concept of value. Probably the most important concept to arise in the business mindset in recent years is that of value. Value is a perception of the customer. Value is seen as the usefulness or necessity of a product. Value for a pharmaceutical customer, a patient, is measured by the drug's effectiveness, its safety, and availability. Value for a pharmaceutical customer, a distributor for instance, is measured by availability, the line item fill rate, delivery time, and other business requirements. Providing value to the customer will guarantee business success. However, determining what that value actually is may require some careful thinking on your part. Using value as a business philosophy allows manufacturers to assess all their activities through the eyes of the customer. If a business activity is not bringing value to the customer, then that activity is a waste. A value stream is a series of steps that a manufacturer takes to produce and deliver a product. There are 3 main parts. The flow of materials, and this is just the movement of raw materials, components, work in progress, and finished product throughout the facility. The transformation of materials, and this is where the raw materials and components and whatnot are converted into the finished product. And then flow of information. And this is the movement of information required to receive, process, release raw materials, components, work in process, and finished product. For instance, the purchase orders for the raw materials, batch records for the batches, any investigation reports that needed to be processed, analytical reports for release of raw materials and finished product. A value stream map is a flow diagram documenting every step of a process. A value stream map is a lean tool used to identify waste and help reduce process cycle times. The value stream map uses a standard set of icons to identify typical steps and activities in a process. What is a process? All processes have inputs, and all processes have outputs, as we will see in a few minutes. The value stream map uses a certain set of icons. As you see on top left, outside sources, which would be raw material suppliers or even customers, are represented by a little house with 3 triangular roofs on it. Movement of materials is shown by a truck. Push and pull arrows are shown as I list them there. And the flow of information, etc., can be seen on these diagrams here. Here's a value stream map. In the upper left-hand corner, we see 2 suppliers, so raw material suppliers who are sending in maybe components or excipients, and they arrive at receiving, which that may take 8 days for them to be received and processed. Then they would move into a blending operation where there's 1 operator, and let's say that takes about 60 minutes, an hour for him to process the blend. Then the blend may sit for 2 days before it moves on to granulating. And there's 2 operators in the granulation, maybe making the granulation solution, 1 guy, and the other one actually operating the granulator. And let's say that operation takes 60 minutes also. Then the granulation will sit for 1 day before going to the compression area. There's 1 tablet press operator, and it may take him 10 hours to compress the entire batch. Then that batch may sit for 25 days before it goes on to packaging, where there may be 5 operators, and maybe take 12 hours to do the final finished packaging. And then it may sit for 15 days before it moves on to being shipped, as it needs to be released. The finished product testing needs to be performed, all reconciliation, the batch record needs to be approved, etc., etc. That gives us a total lead time of 52 days from the minute we get raw materials in, receive orders, and there's only 1 day of value added time in that whole sequence. So only 1 day the process of time was value added. The rest was simply sitting in inventory. And here we see the flow of materials. We see the transformation of materials and the flow of information all on this one diagram. So the entire process of manufacture is captured on one page here. You can view a nice video on value stream mapping using the Minitab Quality Companion tool at this web link here. Value stream mapping is defined as the simple process of directly observing the flows of information and materials as they now occur. This process allows companies to map the flow of products from raw materials entering the facility through all manufacturing process steps to the distribution department as finished product. The mapping process begins with analyzing the current state of both material and information flow. The visual flow is then examined for any non-value-added steps, and as you can see, it's very easy to find them. A future state map is then created as a guide to the desired future state. Lean manufacturing, or lean enterprise, or lean production, or just simply lean, considers any activity that does not provide value to the customer to be waste, which should be eliminated. Lean focuses on eliminating waste, while, as we said before, Six Sigma focuses on reducing variation and improving processes. And we'll see in the next module how those two can be combined to good effect. Lean, as we know today, is a management philosophy that grew out of the Toyota production system and was really popularized by a book by Womack and Jones in 1996, and it became called Lean only in the 1990s. Lean, funnily, is a lean version of lean manufacturing. The Toyota production system is best known as the originator of the 7 wastes. And Lean is credited as the driving force behind the growth of Toyota, once a little tiny company in Japan and now the world's largest automaker. Toyota identified 3 forms of waste: muri, or unreasonable work demands placed on workers by management, asking for too fast or too heavy. I'm sure that will go over big here in the United States. Mura, or unevenness in the execution of work. For example, production push at the end of a quarter to make better numbers. And I've seen this where you want to make quota in order to get your bonuses, so we'll push more product out the door, stack them up, and make the numbers. Muda, or non-value-added work. Muda and Mura, when discovered, are directed back at Muri, so changes can be made to improve the overall process. Muda is the Japanese term for waste. In Lean, Muda is defined as any activity that consumes resources but does not add value to a product or service. Basically, waste is anything you do that the customer is not really willing to pay you for. If not, then it was a waste of time and effort to do it. In pharmaceutical manufacturing, just about every example of waste can fit into one of the following categories. Now, Toyota originally identified 7 deadly wastes: overproduction, defects, unnecessary inventory, overprocessing, excessive transportation, waiting, and unnecessary motion. Overproduction is when more products is produced than is actually ordered by your customers. Can you imagine going out for breakfast and ordering 3 pancakes and seeing the guy make 4, just in case? Defects. Although defects are addressed under Six Sigma, defects are a waste due to the time and cost associated with their disposition, which the customer is not interested in paying you for. Unnecessary inventory. This can take the form of excess raw materials and packaging components and storage, work in progress sitting around, and finished goods just standing in the warehouse being stored there. Overprocessing. Any work done on a product that is not actually required by the customer, and this includes using equipment that is more complex or expensive than is required for that operation. Excessive transportation. Any unnecessary movement of product from one place to another which adds cost to the product but does not add any value. Waiting. Products that are not being processed or shipped to the customer are simply just waiting around. Unnecessary motion. Instead of the product, this refers to the operator or even the equipment. This waste can lead to product damage, equipment wear, and safety issues. The 5 S's, which we'll see in a minute, are used to reduce wasted work movement. There are 2 other wastes that have since been added. Manufacturing products that customers don't want. For example, maybe cheese-flavored soda. Who wants that? And unused human talent. For instance, PhDs pushing a broom. Why would you have a PhD with all that education operating a broom? There are now up to 11 additional wastes, and I won't get into them. The lean people are getting very creative with creating more waste. Lean has a toolbox of techniques used to eliminate waste, and these tools include 5S, Kaizen, and error proofing, Poka-yoke. 5S is a Japanese technique used for improvements in workplace organization and for standardization of work procedures. The steps in this technique are sort, seiri, eliminate unnecessary items from the workplace, remove things that are not necessary, move them to a separate location and reuse them or just get rid of them. Set in order, seiton, efficient and effective storage methods, a place for everything and everything in its place. This is a very old adage, and in my experience I've seen no place for anything and nothing in its place. Shine, seiso, clean and maintain. Establish a daily housekeeping routine. Use this time to identify maintenance issues as you look around as you're cleaning and see if you see anything that's damaged and needs to be fixed. Standardize, seiketsu. Establish best practices. Identify best practices and establish these as routine. And sustain, shitsuke. Continue the improvement for life. Establish a new standard of workplace organization. Now, a spaghetti map is a map of work process showing the actual flow of work and distances traveled during the execution of a task. Work that has not been planned is typically laid out with little thought to efficiency, so the map takes on the appearance of a pile of spaghetti. Processes whose maps look like spaghetti are inefficient time wasters and are often prone to safety issues as well as quality issues. Here we see a process where step 1 to 2 to 3 to 5 goes all over the place. As you see, there's many lines crossing each other, so the flow of materials and flow of personnel have many opportunities to be in collision, and this can cause quality issues as well as safety issues. Here's an example of applying the 5S to a laboratory setting. How exactly do these things fit in? So in the sort step, we would separate laboratory functions. They shouldn't be overlapping where two operators, laboratory operators, are working side by side and bumping into each other. So separate them, move them away from each other. Set in order. Organize your lab materials. Put them in places where they're readily accessible and easy to find. Shine, just housekeeping, basic housekeeping. Keep everything nice and clean. Standardize. Create policies and SOPs. How you should be doing things. Make sure everybody has something to turn to tell them what to do. Sustain. Training and auditing. So training on SOPs and training on the policies and auditing, make sure everybody's doing it correctly. Kaizen is a management philosophy that focuses upon continuous improvement of processes. Kaizen requires all workers to make continuous improvements to all processes. The constant focus on process improvement should ultimately improve the value of the products made by the process. Some companies even employ intense focus on a process by teams over several days to achieve a significant improvement very quickly. This is referred to as a Kaizen blitz. Mistake proofing, or what the Japanese call Poka-yoke, is the technique of designing procedures and devices that prevent mistakes from being made. Examples of Poka-yoke are child-proof caps on prescription medicine, different size blades on polarizing electrical plugs so they can't be plugged in. A 3-prong plug is a good example of Poka-yoke. There's only one way to plug it into the wall. You can't plug it in incorrectly. How many of you have been frustrated by USB sticks that you're always putting them in the wrong way because they're not designed to go in one way only. You can try to put it in the wrong way. Different size fuel dispensing nozzles to prevent cross-fueling. You want to make sure that you're not putting diesel into a regular or regular into a diesel engine. Different hose connectors for breathing air lines and nitrogen lines. This grew out of the fact that quite often, this happened way too many times, people who were hooking up to breathing air hooked up to a nitrogen line instead. This resulted in fatalities. So this is an important Poka-yoke that has prevented future fatalities. They don't happen now because you cannot hook up incorrectly. Mistake proofing also provides the detection of errors and stoppage of those errors before they become defects by using shutdowns, controls, or warnings. Examples of detection measures may include, some of you may be familiar with coffee pots that have automatic shut-offs when they reach certain temperatures or times. And other small appliances have these types of features. Poka-yoke can also be used on FMEAs, failure modes and effects analysis, which we'll look at later on in the course, and any really high-risk items where we see very serious risks. Poka-yoke techniques can be used to prevent the failures from ever happening. Theory of constraints. If the cause of patients waiting for prescription medicines, for instance, is a backwater due to tablet manufacturing scheduling errors, tablet manufacturing bottlenecks, tablet raw material lead times, finished product and inventory shortages, then Six Sigma managers utilize a tool called the theory of constraints to help management make decisions to reduce and/or eliminate the problems. Theory of constraints focuses on system improvements by first paying attention to the weakest link of the system. A constraint can be a physical, for instance, a machine, a milling machine, or non-physical, the release of a batch by the lab. And the theory of constraints has 5 steps. 1, identify and prioritize the constraints. 2, exploit the constraints. So try to optimize the process without major changes to the constraint. 3, subordinate everything else. Based on the constraint, subordinate other processes to match that constraint. So there's no backup of materials and things like that. Slow everything down to meet the speed of the one constraint. Break the constraint. 4, if the output does not meet requirements, consider making major changes to the constraint. For instance, maybe buying new equipment that's faster. 5, repeat. Once the constraint is broken, return to step 1. With the initial constraint now resolved, a new constraint will now appear. Those of you who have done any plumbing will know when you have a leak somewhere on newly installed piping, once you tighten up and solve that leak, the pressure now moves somewhere else and at least starts leaking somewhere else. And you keep tightening and tightening until none of the joints leak anymore. Theory of constraints metrics defines 3 operational measures to determine whether an organization is moving towards its goal. First off, you would see increased throughput, you would see decreased inventory, and also decreased operating expenses. The following 4 measures are used to identify the results of the overall organization. So net profit, return on investment, overall productivity, and turnover. Now, lean manufacturing simply is a theory of production that considers any expenditure of resources for anything other than the creation of value for the customer to be wasteful, and you should target them for elimination.